Today I want to talk about heat pumps for cooling. And yes, it might seem like a bit of an idiosyncrasy, but heat pumps can provide cooling. And when you understand the nature of how we provide cooling, the term heat pump for cooling will make a lot more sense. Most of us are used to air conditioning for cooling. So having a unit that sits outside your house, there's a fan in it, it makes a whole bunch of noise. You put your hand over top of it in the middle of the summer, it's got warm air coming off of it. That is a condenser, and that's hooked up to what we call an evaporator, which is another coil that sits typically inside of our ductwork system on top of our furnace. Now, the evaporator's job is to absorb heat from the indoor air. So as the air moves, the furnace has a blower in it that moves air across the evaporator coil. As that warm air moves across the coil, the refrigerant on the inside of the coil is very cold, and so that promotes heat transfer between that warm air into the refrigerant. The compressor is basically our pump that pumps that now warmed refrigerant to the outdoor unit, which is called our condenser, and the job of the condenser is to release heat into the outdoor air. So that's what it does. When you put your hand over top of the condenser, you've got much warmer air than the ambient air outside. The condenser is a fan over a coil, and that's just moving air over that coil, releasing that heat into the outdoor air. And so when you think about heat pump, an air conditioner is a heat pump. The difference between an air conditioner and the heat pump that we're talking about today is that a heat pump's reversible. So it can choose where the condenser and where the evaporator are. So if we want to heat with a heat pump, the evaporator switches its spot. So it moves, it doesn't physically move, but a valve switches and says that outdoor unit is now going to be my evaporator. That's where I want to absorb the heat. And the indoor unit is now going to be my condenser. That's where I want to release the heat. So it switches between, but essentially the refrigeration circuit of both an air conditioner and a heat pump are exactly the same, except for the fact that the heat pump has a couple of pieces that allow it to be reversible. Now, the question is, isn't it a little counterintuitive to be trying to reject or release heat into hot outdoor air? So the day that you need your air conditioner the most is the day that it's hottest outside, right? It's sweltering hot, you need cooling in the house. We need to get rid of that heat, and that's how we do that. Well, it's correct. The day that you need your air conditioner the most is the day that it is least efficient, because it is working the hardest to reject that heat into the outdoor air. Now, thankfully, the hottest day of the year when we size and select these systems only occurs a certain percentage of the time. So it's not like every day that's happening, although in some regions, due to climate change and warming, that's happening more and more, and we're seeing that in Ontario through history and records of weather data. So certainly that's a bit of a concern. And depending on the position of the heat pump or the air conditioner, temperatures can be warmer than ambient. So let's say your outdoor unit was sitting in direct sunlight or on a tall roof with black tar roof. That can be much warmer than ambient temperatures, and that will further impact the performance and the efficiency of that heat pump or that air conditioner. Now, the same is true for an air source heat pump in the heating mode. So now that evaporator is outdoors and we're trying to extract heat from the outdoor air. Now, don't worry, there's a lot of heat in cold outdoor air. If anyone knows the temperature of absolute zero, minus 273 degrees Celsius or 0 Kelvin, that is the temperature where a substance cannot be cooled any further. There's no way to further cool that beyond that temperature. But every degree above minus 273, there's some heat in that. So if you think about typical cold temperatures that we experience in Ontario, maybe not this winter, but last winter, maybe a couple days this winter, we had minus 30 something, minus 40 with wind chills. So that is a long way from minus 273. So there's still a fair amount of heat in that outdoor air at those temperatures. Now, that is still a challenge for some air-to-air air source heat pumps to, number one, maintain their capacity. So how much heat they put out is going to vary or decline as the outdoor temperature declines. So it gets harder to pull heat out it loses its ability to extract that heat. It also, because it gets harder, becomes less efficient at extracting the heat it does get. And so those are considerations when we're designers looking at what system is right for what home. Now the next option, I want to talk about a couple of different heat pumps here because all heat pumps provide cooling, so we figured that part out. So the next option is a ground source heat pump. So this is a termed water to air heat pump. Now we can also have water to water heat pumps for hydronic systems, but I'm going to focus on the air side. So you have a ductwork system in your house, you have a furnace today, an air conditioner today, and you're looking at a heat pump to replace it. A ground source heat pump will also provide cooling, and the same benefit that we have with a ground source heat pump in the wintertime is that we're connected to a ground loop heat exchanger, that piping network that we put into the ground as our source for heating in the winter, and now it becomes our sink for cooling in the summer. And the benefit's the same. In the winter, that source is a relatively warm source compared to the outdoor air. If it's minus 25 degrees out, it's still 8 to 10 degrees Celsius, about 5-6 feet down below the surface once you get below that frost line. So that's a lot of low-grade heat for our refrigeration system to absorb and use effectively to provide heat into the home. So on the flip side, in cooling, that 8 to 10 degrees Celsius soil becomes a great cool place to put the heat from the home, rejected from the inside of the home into that ground heat exchanger into the ground, compared to a 30, 35, 40 degrees Celsius outdoor air temperature. So now you can see how that heat pump system can maintain not only its capacity, but its performance throughout the entire year. And that has some more global effects as we start to look at electrifying all of our homes. That becomes more of a consideration for our utility companies to look at as well. The third type of heat pump I want to talk about is a little bit newer in the sense that in North American market, and I'm talking about it because I think it's a heat pump that fits well between those two options. So let's say you don't have the ability to install the ground heat exchanger infrastructure for a geothermal system. Maybe you're in an urban center and you have to drill down, which is totally possible. Ground heat exchangers are installed vertically all the time, but maybe the situation just doesn't fit your application quite right. But you want something that'll provide almost the same level of performance, maintain almost the same level of capacity as a ground source heat pump, but you don't want to install that infrastructure. And you want something that has better efficiency than an air source heat pump, air-to-air system. In between is an air-to-water system. Now, if you talk to most people about this today, they think that's where you apply an air-to-water on a hydronic system typically. And that's totally true because the nature of it, air-to-water, suggests that we're taking heat, we're taking it out of an airstream, and we're going to dump it into a water stream. And that works really well with things like in-floor heating. But one of the opportunities that is emerging is the ability for an air-to-water system to chill water. It's still a heat pump, so it's reversible. It can chill water. And there are such things we call air handlers or hydronic air handlers, where we can send heated or chilled water to that air handler, blow air across that heated or chilled water coil, and get heat into the house or extract heat from the house. Now, the advantage in cooling of an air-to-water system is that that coil that's extracting the heat, we've got a lot of control over the temperature that coil is. In our refrigeration system, on an air-to-air system, or your typical air conditioner, we're limited in what we can do. That coil temperature is going to be in a certain range, and its performance is totally acceptable. We may be able to do a little bit more with that air-to-water system because we can control the temperature of the chilled water that we send to that coil. Now, the next thing is we can also provide integrated domestic hot water into that solution as well. So if I were to buy an air-to-air heat pump today, but I also wanted to have a heat pump for my water heating, the only option I would have is to buy a separate heat pump water heater unit. The downfall of that is they're limited in capacity. I shouldn't say capacity. They're limited in performance. They're extracting their heat from the indoor space, which the impact of that is marginal. There's been studies on that. But what if I wanted the highest performance domestic hot water heating and I didn't want to sacrifice heat that's in the indoor space, and I wanted the system to be totally integrated so I can get the benefit of sharing some of that thermal energy? Well, a air-to-water heat pump can provide an integrated domestic hot water solution along with chilled water, hot water, heating and cooling, whether or not you have a radiant system. So it's something certainly to consider because it falls in between those two options of air-to-air and ground source heat pumps. A lot of the benefits of a ground source heat pump system without the infrastructure costs, with a lot of the benefits of an air-to-air system, so a little bit less complex installation, less disruption, more flexibility perhaps than just an air-to-air system. So there's a lot of things to consider there. Thanks very much for checking out the video. I know it was a long one. I hope this answers some questions about cooling with a heat pump. Check out our website, evolvethermal.com. We help homeowners and contractors navigate the array of heat pump options and find the right heat pump system for your home and your project. Thanks very much.